Why on earth would we ever care about uniform continuity? Are mathematicians just making up these fancy definitions just for fun? No, absolutely not. Uniform continuity is super important, and I want to try to sell it for one particular reason. Continuity, just straight up old school continuity, says that if your inputs are getting really, really close to something in the domain, then the outputs will be really, really close to f of that point in the domain. But what if your inputs are getting really, really close to something that's not in the domain? For instance, here, if we get really, really, really close to 0, we can't say anything about the outputs. They could be actually any number between -1 and 1. Exactly the same thing happens here. As our inputs get really, really close to 0, our outputs are blowing up. They're going towards infinity. But this is a continuous function. 1 over x is completely continuous at every point in its domain. And this friendly function here is also completely continuous at every point in its domain. However, both of these functions lack the property of being uniformly continuous, and that is the issue we've been talking about in the recent videos. If you do have a function that is uniformly continuous on its domain, this does not happen. No matter where your points are going, as long as they're converging to something, the outputs will be converging to something. And this is basically how we get that theorem we talked about in the last video about filling in the values at the endpoints. And really what it's showing is that our functions that are uniformly continuous are preserving sequences that are convergent, or if you like, sequences that are Cauchy. I think this is super important because keeping track of what things are, how close or how far apart they are, is super important in lots of applications. And later, when we want to prove, for instance, that continuous functions are integrable, in other words, we can define area under the curve for some function like this, we actually don't use the continuity property. We use the fact that they are uniformly continuous because we only talk about integrals on closed intervals. Uniform continuity is so important, and the fact that we have these simple tests for figuring out when something is uniformly continuous makes it all the better.